Hi everyone, welcome to your first lesson of GCSE mathematics. It is very exciting that we're starting this journey together, but before we actually start our new learning, I think it's really important that we go through some things that I need you to have in the background, okay? And we're really going to look today at your number fluency skills and also your measures, okay? So by measures we mean all sorts of things like distance and volume, etc., okay? So really important that we do this today. I need you to pay very close attention. We're going to run this as a series of remember tasks, okay? Only a couple of questions at a time. So I'll pause it and I'll say, can you do the questions? You'll pause the video, you'll do the questions, and then we'll go through the answers together, okay? And in that way, when we start the new learning in the next video, you'll be nice and comfortable with this background information that you need for it, okay? So, right, let's make that full screen for you so it's easier to see. Okay, so can you pause now and try those first two questions? Once you're done, you can press play and we'll go through the answers together. Okay, thanks for doing those. Just getting this set up for us so that we can see. I feel like that's very important. Okay. All right, little note for you as well to get you excited. Right, so we're going to start with question 1. Okay, if we look at question 1, it says to write down the value of the digit 2 in these numbers. So what they mean by that, they don't mean the second digit, they mean actually the digit that is a 2, okay? And that's really important to get because you don't want to do the wrong thing. So if we look at part A, it's 125. You know, I said that and it actually said 125. And since that's the 2, we would say that the value of this is 20. So the value of the digit 2 is actually 20. They want you to write down the number. They don't want you to write down the word 20, okay? Right, part B, we have 2,300. So if it's 2,300, then we know that the value of the 2 must be 2,000. Okay? If they did want it in words, they should write down to write it in words. Right, so part C, 628,374. Okay, so we're looking at the 2. When we say it, it's 620,000. So I know that my answer should be 20,000. Okay, part D, 47.28. Okay, well, that's 2/10, which we write as 0.2. Okay. Part E, 0.372. 1, 2, 3 spaces along, that's 2 thousandths. So if we just want the value of that 2, then it's 0.002. Okay, sorry about the color change. And for part F, we have 8.021. Okay, so the 2 is in the hundredths, so we make sure that it's in the hundredths when we write down the value. Okay, so hopefully that makes sense to you. Yes, we want to look at the place value. Where is that 2? Okay, and then using that, we are able to write down the value of just the 2. All right, lovely. Question 2. Write these decimal numbers in order of size. Start with the largest. Okay, well, my recommendation for this is to write down your numbers. Give yourself a bit of space. Okay, and notice they don't all have the same number of decimal places. So actually I'm going to fix that, okay, by putting in a 0 there. And now they all have 2 decimal places, so it's going to be easier to compare them. Okay, some of them start with a 3. They're clearly going to be smaller than the ones that start with a 4. So we're going to look at the ones that start with a 4 or a 3. Well, the question says, let's look back at it, start with the largest. So actually we're going to look at the 4s first. Okay, and of the 4s, 61 is bigger than 30, which is bigger than 12. So that means that 61 hundredths is bigger than 31 hundredths, which is bigger than 12 hundredths. Okay, so that's going to mean that we're going to write 4.61 first, followed by 4.30, followed by 4.12. And now we look at our 3s. Well, 3.12 12 is bigger than 9. Okay, so we're going to write 3.12, and then we are going to write 3.09. Now, we have to be careful. They may not say start with the largest. They might say descending in a question, which means the same thing. So descending means from largest to smallest. If you didn't know that, you should write that down in your notes, okay? And ascending means from smallest to largest. Okay, so those are two very key definitions, which I would strongly suggest that you put in your notes because they are very important. So you can pause the video and do that now. Okay, all right, thank you for writing those down. Okay, so now I would like you to move on to this question here, or two questions, question 3 and 4. Okay, you should be able to see that in the video, so I'm not going to make it full screen. All right, pause the video, try questions 3 and 4, and then we will go through them together. Okay, thank you for doing questions 3 and 4. Let's take a look at them. All right, so we can see in question 3 that we're dealing with rounding, but in this case to the nearest 1,000, 100, 10, and to the nearest integer, which means the nearest whole number. Okay, so let's look at part A, where they're wanting us to round to the nearest 1,000. So that is 2,385. Okay, well, we're rounding to the nearest 1,000. We need to think about halfway. And halfway is going to be the 500 mark. So 2,500, we're going to say, would be closer to 3,000. But 385 is less than 500. So an easy way to help yourself with this is you can draw a line after the 1,000, because we're rounding to the nearest 1,000. And you can circle that first number. Now, 3 is less than 5. So we know that this is less than 300. So that shouldn't change, that 2. It should stay at 2,000. So we can say that it's approximately 2,000. Okay, and that is rounding it to the nearest 1,000. Okay, so we follow a similar process for our other ones, but we just pay attention to what they're saying to round to. All right, so this one is 872, and they're saying to round to the nearest 100. So here's my hundreds. We can put a line there to help ourselves, and we can circle the 7. Okay, 7 is definitely 5 or higher. Okay, and therefore 72 we know is bigger than 50, which means that's going to round up to a 9. So it's actually approximately 900 if we round to the nearest 100. Part C, we have 59. Okay, now 59, we're rounding now to the nearest 10. Okay, so here's my 10s. I'm going to put my line after it and circle the next number. Is it 5 or higher? Yes, which means I'm going to round up to 60. It's closer to 60 than it is to 50. That's what you need to be thinking about. Okay, and my last one, which it says to the nearest integer. Remember, that means whole number. Okay, so we've got 84.19. Here's my whole number, or my integer value. So put our line here and circle the 1. Okay, well, a 1 is less than 5, so you shouldn't be rounding this up. It should stay the same. So we say that that is approximately 84. And that would be to the nearest integer. There's no decimals. Okay, so I'm hoping that makes sense. You do have 2 rules, though, that will help you. Okay, if less than 5, we stay the same. Okay, so when we looked at this one, we kept that as a 2, so we had 2,000. That was less than 5. Okay, when we looked at the 84.19, the 1 was less than 5, so that stayed as a 4, so we had 84. Okay, so if less than 5, stay the same. If 5 or higher, round up. Okay, and that's what happened in these two. The 7 was 5 or higher, so we made it 900. The 9 was 5 or higher, so we made it 60. Okay, so those two little rules should really help you with your rounding. Okay, so please write those down. You can pause the video if you need to, and then press play again, okay? Right. Question 4. We need to work these out. So here we are multiplying by powers of 10. And we're dividing by powers of 10. So let's take a look. So for part A, we're multiplying 25 by 100. Okay, well, that's 2 more place values we need to put onto here. Okay, please don't say add on because we're not actually adding. We're multiplying it by a power of 10, which happens to be 100. Okay, and that would be 2500. Okay, so 2,500. Now, in part B, they're wanting us to divide. Well, if I divide by 10, okay, my place values will change, okay? We start with 14. If I divide by 10, my original decimal's here, okay? Our numbers shift by a power of 10 smaller, which means the decimal moves 1 place, okay, to the left. So that is 1.4. Okay. If this was 100, it would have moved 2. If it was 1,000, it would have moved 3 spaces. Right. Part C. 3.5 times 1,000. Okay. Careful. Don't just put 3 zeros on. Okay. Because actually we have now a decimal place. Okay. This is in the tenths. So actually, if you're going to move it to the right by 3 spaces, 1, 2, 3, you'd only have 2 zeros as placeholders, okay? So that is going to equal 3,500. Part D, we have 138.6 divided by 100. Okay, so again, now we have 2 place values that we are changing by. We're getting smaller by 2 place values. Okay, so we're going to the left with our decimal place, and that gives us 1.386. Part E, we're multiplying 4.7 times 1 million. Right, so that's 1, 2, 3, 4, 5, 6 places that we are increasing by. So 1, 2, 3, 4, 5, 6 would give you 5 zeros. 1, 2, 3, 4, 5. Okay, and that number is 4,700,000. And part F, 20 times 30. Okay, so now we know that 2 times 3 is 6, but we need to make sure that we actually have the correct number of place values, okay? So if we did this, I could split it up. I am allowed to change this to 2 times 10 times 3 times 10, because 2 times 10 is 20, and 3 times 10 is 30. I can now bring the numbers together. 2 times 3 times 10 times 10. So what I've done is I've reordered them. I've put the 2 times 3 together because that's easy to figure out, and the powers of 10 together. Well, 2 times 3 is 6. 10 times 10 is 100. So 6 times 100 gives me 600. Okay? All right, so that's a really nice way to deal with multiplication when the numbers get larger. You can split them up as long as you still are multiplying together correctly. Okay, that's perfectly allowed. Okay, so your turn again. Can you press pause, try questions 5, 6, and 7, and then we will go through them together. All right, well done, guys. Okay. So let's look at question 5 first. This is dealing with our addition and subtraction. I would suggest that whenever you're adding and subtracting, it is easiest to do column method, okay? So we're going to do 25 plus 32. You need to make sure you line up your place values. You can see that the ones are lined up in the tens. If I had hundreds, I'd have to line them up and so on, okay? 5 plus 2 is 7. 2 plus 3 is 5, and so we are done at 57. So that was part A. Part B, we have 153. Now, when I write down a 19, I'm not going to start on this side. Okay, I'm going to start here because the 9 is in the ones and the 1 is in the tens. Okay, it's worth 10. Now I can add 3 plus 9 is 12, so put the 2, okay, and then I carry the 10 because actually the 10 should go in the tens column. We put a 1 there to remind ourselves it's technically 10, okay? 1 plus 5 is 6 plus 1 is 7, and then we just had 100, so 172, final answer. Part C, we are subtracting, so we have 87 minus 29. Again, note I made sure my place values were correct. Okay, here's my ones, here's my tens. 7 minus 9, I can technically do, but that's a negative number, so that's not going to help. So I have to exchange. I have to take 10, okay, away from here, making that 70, and place it with the 7 to make that 17. We call that exchanging because I'm actually taking 10 and moving it over to the ones column. Okay, so now we have 17 minus 9, which is 8, and 7 minus 2 is 5. All right, final answer, 58. Part D, we have 476 minus 38. Okay, so again, 6 minus 8, not really feasible in this context, so we are going to exchange, make that 60, okay, and exchange the tens. We get 16 minus 8, which is 8, 6 minus the 3, which is 3, and then 4 minus 0 is 4. So 438 would be our final answer. Lovely. Question 6, we are multiplying. Okay, I'm going to teach you 2 methods for this, all right, because I want you to choose what you prefer. All right, the first method we are going to do is a column method. Okay, but remember, you're going to choose which one you prefer here, and it doesn't matter which one you choose, all right, but there's 2 methods that are really good to use. 0 times 5. So when we do this, we start with the ones, and the ones number is a 0. So 0 times anything is 0. 0 times 5 is 0. So when we do this, I need you to pay attention. We're going ones times ones first. Okay? That's the first step. So I'll put a 1 there. The second step, and I'm going to use different colors to help you, is to do ones times 2. So that's the second step. So the ones times the tens, 0 times 2 is still 0. Okay, so I've done the ones, that's not a problem. I now have 0, that's fine. I'm now moving over to the tens column though, but I don't want to think about it as tens, so I'm going to put a placeholder in the ones section, which is a 0, so that I can treat that like it's a 3. I've dealt with the fact that it's actually 30 by putting the 0 there. So now I can do 3 times 5, so that's your next step. So you go back to multiplying. So that's the third step. Okay, so 3 times 5 is 15. Okay, 15, technically 150, I'm going to have to put a 1 in the hundreds column so that I can add that on. All right, and our very last step, okay, is to now do the 3 times the 2. And 3 times 2 is 6, okay, but we had a 1 we had to add to it, so that's a 7. We can now add that up, and in this case, that's 750, okay? So we always start with the ones. We multiply by the ones above first, then the tens. If we had hundreds, we would then go to the hundreds. We put a placeholder down of a 0 when we move to the tens. 3 times 5. Okay, 3 times 2, so that's the tens times the ones, then the tens times the tens. If I had hundreds, I'd do the tens times the hundreds, okay, and that's what we will do on the next question once I teach you one more method. Okay, so let's say we're struggling a little bit with that. It's not a problem. We're going to use something called the grid method, okay? In this case, because 30 doesn't have any ones, I could just put 30 down, all right, and I'm multiplying it by both a 20 and a 5. So I split up my other number into the 20 and the 5. And we now multiply. It's called a multiplication table. Okay? 20 times 30. Well, 2 times 3 is 6. And then times 100. Okay? And 5 times 30, 5 times 3 is 15, and then times the 10, because that's 30, is 150. You then take the values inside your table and you add them together. Okay? So 600 plus 150 is equal to 750. So as we can see, both methods work. It's just you're going to have to think which one is easiest for you, and then that's the one you can stick to. Okay? Right, so that was part A. Let's look at part B now. We have 125 times 234. Okay, so we're going to start with our column method. I'm not going to do the highlighting. Okay, I only showed you that once so that it would be clear. Now I'm just going to remind you of the order. Okay, so first we're going to do ones times ones. Okay, 4 times 5 is 20. So I put a 0, and then I'm going to call this a baby 2 because I don't want it to get in my way, and I have to add it on in a moment. So 4 times 5 is 20, carry the 2. 4 times 2 is 8, add the 2 is 10, carry the 1. 4 times 1 is 4, plus the 1 is 5. That's done. We're moving over to the 3, which is in the tens column, so I have to put a placeholder. 3 times 5 is 15, 5, carry the 1. 3 times 2 is 6, plus the 1 is 7, don't need to carry anything, and 3 times 1 is 3. Right, we move over to the hundreds, we need 2 placeholders, because it's in the hundreds, so put 2 zeros. Okay, 2 times 5 is 10, 0, carry the 1. 2 times 2 is 4, plus the 1, which is 5. And finally, 2 times 1 is 2. Okay, we can now add them up. Ignore those little numbers, that's why we drew them smaller. Okay, 0, 0, 0 is 0 when we add. 0 plus 5 plus 0 is 5. 5 plus 7 plus 0 is 12. Carry the 1. 3 plus 5 is 8 plus the 1 is 9 and a 2. Okay, and we're done. So that's one method. We can also do the grid method. We're going to have to split them up into their place values. So we're going to have a 200, a 30, and a 4. We're multiplying by 100, 20, and 5. Okay? Now, in an exam, it does take time to draw these, so I'm quite happy if you space it out like that, or you can use a ruler and put in your grid lines. 200 times 100, well, 2 times 1 is 2, and then we have 1, 2, 3, 4 places. Okay? 30 times 100, 3,000. 4 times 100 is 400. Okay, so these 3 will be the first 3 that we add together in a moment. 20 times 200, 4 and then 3 places. 30 times 20 is going to be 6 and then 2 places. 4 times 20 is 80. Okay. And finally, 5 times 200 is 1,000, 5 times 30 is 150, and 5 times 4 is 20. Okay, so all those ones that I've highlighted, we now need to add together. All right, you might be able to do some of it in your head and then add them together. So let's do this one. This is going to be 23,400. So 23400. 4,680, 4,680. Notice I've been careful with lining them up. And 1,170. So 1,170. Okay, now if I add those, I'll get the final answer. 0 plus 0 plus 0 is 0. 8 plus 7 is 15. Carry the 1. 1, 2, plus 10 is 12. Carry the 1. 3 plus 4 plus 1 is 8, plus 1 is 9, and then the 2 plus 0 is 2. And as you can see, they match, same answer, so up to you whether you use the grid method or the column method. Either, fine. Well done. Okay, so question 7. Right, look at the set of numbers, 4, 8, 12, 15, 27, 29, 36, 49. Which are odd numbers? Okay, so we've got a list, and we need to find the odd numbers. Now, what you need to remember is what an odd number is. An odd number ends in a 1, a 3, a 5, a 7, or a 9. So your key values, 1, 3, 5, 7, 9. You might have something in front of that, but they have to end in those. Okay, so for us, we have 15, we have 27, we have 29, and we have 49 from that list. Okay, so well done if you got that. Part B, divisible by 2. Well, that's the same as saying even. Okay, so for divisible by 2, we are looking for even numbers. Okay, and that's going to be our 4, 8, 12, and 36. Part C, we're looking for multiples of 3. So that means something I can divide by 3. It's in the 3 times table. Okay? So how you think about that is up to you, but it's to do with multiplying. All right, so if I did 4 divided by 3, I would not get an integer value or a whole number. 8 divided by 3, no. 12 divided by 3 is 4, so 12 is correct. Okay, 15 divided by 3 is 5. 15 is correct. 27 divided by 3 is 9, so that's correct. 36 divided by 3 is 12, so that's correct. Okay, and 49, nope, doesn't divide by 3, divides by 7, but not 3. 29 is a prime number, so that's not going to work. Okay, part D, square numbers, meaning that it's created by a number times itself. Okay, so for example, I'll list this first few square numbers. If you think about 1 times 1 is equal to 1, so 1 is a square number. 2 times 2 is equal to 4. So 4 is a square number. 3 times 3 is equal to 9. So 9 is a square number, and so on. So let's find them. Okay, so for our square numbers, we have the 4, because that's 2 times 2. We have the 36, because that's 6 times 6. And finally the 49, because that is 7 times 7. Okay, and part E, cube numbers. Now, a cube number would be made by a number times itself again. So 1 is a cube number. 8 is a cube number. 27 is a cube number, and so on. Okay, so our answers for the cube numbers, in this case, we can see are going to be 8 and 27. Okay, there aren't any others on that list. Lovely, well done. Okay, so you're going to try questions 8, 9, and 10 now, please. Press pause, and then press play when you're ready to go through the answers. Okay, lovely, well done. All right, so it says write the prime numbers between 4 and 10. Well, I don't think we can do that until we've reviewed the prime numbers. Prime numbers, remember, are numbers that you can only divide by 1 and itself. So let's write that down. Prime numbers only have factors of 1 and itself. Okay, right. So list them between 4 and 10. Well, 4 is not a prime number because you can divide by 2, 4, and 1. So not just 4 and 1. But 5, I can only divide by 5 and 1, so that's correct. 6 is even, that won't work, it divides by 2. 7, I can only divide by 7 and 1. 8 is even, it divides by 2, and 9 also divides by 3, and 10 also divides by 2 and 5. So yes, so it's only 5 and 7. Okay, question 9, list the factors of 24. Okay, so we're going to like to do this in pairs, right? And there's different ways to think about this, but by pairs, by factor pairs, I mean two numbers that multiply to give you 24. And we're always going to start with 1 and 24. So 1 and the number itself. And then you're going to think to yourself, does it divide by 2? That's the next number. Yes, it does. 2 and 12. Does it divide by 3? 3 and 8. Does it divide by 4? Yep, 4 and 6. It doesn't divide by 5, and these are so close together that if we swapped, we'd just go the other way, and so we're done. Okay, so use a little bit of a number line to help you with that, and those are factors, and now they're actually in order as well. But notice I gave myself space because I didn't know how many of these there would be, how many factors, okay? So it works because 1 times 24 works, 2 times 12 is 24, 3 times 8 is 24, and 4 times 6 is 24. I now have all of my factors. Okay, and question 10 is division. So let's take a look at these. 8 into 816. Okay, so you're going to say, how many times does 8 go into 8? Once. How many times does 8 divide into 1? 0. Make sure you're now thinking about this as being 16 because you haven't used that 10 yet. So how many times does 8 go into 16? It goes twice. And so 102 is my answer. That was part A. Part B, we have 6 into 282. All right, so 6 does not go into 2. So that's 0, and then carry the 2 because now that's going to be 28. 6 goes into 28 4 times, remainder 4. So 6 goes into 42 7 times. Done. So your answer is 47. Part C, we have 5 into 67. Now, I already know that's not going to go perfectly, so I'm going to put a 0.0 so that I can get my decimal value. 5 goes into 6 once with a remainder of 1. 5 goes into 17 3 times with a remainder of 2. Why? Because 3 times 5 is 15 and 17 minus 15 is 2. Put your decimal directly above when you need to carry into the decimals, okay? 5 goes into 24 times, so my answer is 13.4. Now, D is an interesting one, okay? I'm not really a huge fan of dividing by double digits, okay, or numbers in the tens. So we're going to try something else first. We're going to write it as a fraction and cancel it down. I am allowed to do that. I'm going to cancel it down as far as I can, and then I can use division or short division to solve it. So they both divide by 2, okay? So half of 14 is 7. Half of 252, well, half of 250 is 125, and half of 2 is 1, so that would be 126. So what I've done to do that is I've divided both the top and the bottom by 2. I've cut them in half. Now, 126 divided by 7 is a lot easier to do, so now we can do this. So 7 into 126, okay? 7 doesn't go into 1, so 0, carry the 1. 7 goes into 12 once, remainder 5, and 7 goes into 56 8 times. So my answer is 18, okay? And we're going to use a similar method for E. All right, so we're going to start with 1,278 over 12. They divide by 2. Okay, so that's going to give me, well, half of 1,200 is 600. Half of 70 is 35, so 635. And half of 8 is 4, so 639. 639, we divided that by 2 over 6. Now I'm perfectly happy to work on this using our other method. So 6 into 639. Let's take a look. 6 goes into 6 once. 6 goes into 3. Nope, 0. Carry the 3. I'm going to need something else here. 6 goes into 39 6 times to give us 36 with a remainder of 3. And 6 goes into 35 times, so we have 106.5. So when you have a situation where actually the number you're dividing in is larger than you'd like it to be, you can try using a fraction and canceling down so that you get an easier division to work with. That's a really good technique, okay, to make sure that you can confidently do your division. Right, so well done, proud of you. Let's have you move to the next questions. Okay, so press pause, have a go, and then we will go through the answers together. Okay, good. Okay, so work out the square root, the square of 9. Read carefully. The square of 9 is going to be 9 squared, which means 9 times 9, which is 81. So when I say square of, they mean to square something. But when they say square root, they want you to go in reverse. So what number times itself gives you 64? Well, that would be 8, because 8 times 8 is 64. Part C, the cube of 4, so they mean 4 cubed, which is 4 times 4 times 4, which is 16 times 4, which gives us 64. Okay, part D, they want the square root of 16, and square root of 16 is going to be 4, because 4 times 4 equals 16. So I'm hoping that one's okay. Question 12, work out 5 plus a negative 3. Well, let's think about this way. If you're adding negativity, it's the same as taking away positivity. Yes, it's more negative. Okay, so this is exactly the same as saying 5 take away 3, which is 2. Part B, we have 6 take away 8. If you struggle a little bit with this, a way to think about temperature, you're taking away a larger number, so it's going to be more negative. I start with 6 degrees, I drop 8 degrees, I'm going to be below 0 by 2. Okay, so that's negative 2. Part C, we have negative 7 add 2. Okay, so we're at negative 7 degrees, we add 2 degrees, we're going to go up to negative 5. Closer to 0 because we're getting more positive. D, we have negative 4 take away a negative 3. So remember in part A, we were adding a negative number, so we were adding negativity, we were getting more negative. Here we're taking away a negative, so I'd like to think about that as taking away negativity, which means you would become more positive, okay? Right, so in this case, if I'm taking away a negative 3, that's the same as adding 3. So we can write this as negative 4 plus 3, which is negative 1. Part E, we have negative 3 add 10. Okay, so again, if we thought about temperature, you're negative 3, that's 3 below 0. You're going to add 3 to get to 0, and you're going to be left with 7. So the answer to that one is 7. And F, negative 1 minus negative 4. Okay, so again, we're taking away negativity. That means we're becoming more positive. So negative 1 plus 4 is going to be 3. Lovely. Right, question 13. What number is 20 more than negative 40? Okay, right, 20 more than negative 40. Well, 20 more would mean we're adding it to the negative 40. So we're going to write this as negative 40 plus 20. And now it's easier to see that the answer is negative 20. Okay, so you need to write it out mathematically even though they gave it to you in words. All right, so that's part A. 30 less than negative 50. Well, if they're saying less, that's subtraction. So we start with a negative 50 and we take away 30 because it wants 30 less. All right, now if I'm already at negative 50 degrees and I drop another 30, we're going to get colder, so that's negative 80. All right, so with your negatives and with your adding and subtracting negatives, I really want you to think about temperature. It does help it make a lot more sense, okay? Right, so please pause, try questions 14 to 17, and then we'll go through the answers together. Okay, well done, guys. Really proud of you. Okay, let's take a look. So here we are doing negative 5 times 2. Well, that's 2 sets of negative 5, so it's going to be negative 10. Okay. Part B, we have 5 times negative 2. Very similar. This is 5 sets of negative 2, okay, which is going to be also negative 10. Part C, we have negative 5 times negative 2. Well, a negative times a negative is always going to give you a positive. So let's write that down so you remember. Negative times negative equals positive. Okay, so in this case, it's like saying 5 lots of 2, which is 10. Part D, we have 12 divided by negative 3. Okay, well, you're dividing by a negative, just like if you multiplied by a negative, you would have a negative answer, so that is negative 4. Okay, part E, we have negative 12 divided by 3. Negative 12 divided by 3, similarly again, a negative divided by a positive, just like a positive divided by a negative, is going to be negative, so that is negative 4 as well. And part F, we have negative 12 divided by negative 3. So just like we had a negative times a negative gives you a positive, a negative divided by a negative also gives you a positive. So my answer here is going to be positive 4. All right, well done. Question 15 says, work out these values. Now this is adding and subtracting, but with decimals. We need to make sure we line up at the decimal. So I can write the 3.1, but when I write the next number, 5.27, I've lined up at the decimal. I'm going to put in a placeholder there so that it's very clear, and then I can add. 0 plus 7 is 7. 1 plus 2 is 3. Don't forget your decimal. 3 plus 5 is 8. Done. Okay, so that's part A. Part B, we're subtracting. We're still lining up at the decimal, so that's 16.4 minus, now careful, 9.18. So I do need my placeholder there. Okay, we're subtracting. 0 take away 8 is negative. That's not going to work. So we're going to exchange. We're going to take one of the tenths, okay, and move it to the hundredths. So that's going to be 10 hundredths. Okay, so 10 take away 8 is 2. 3 take away 1 is 2. 6 take away 9, nope, not happening. So we are going to make that 0, okay, and that's actually 16 take away 9, which is 7. So we have 7.22 as our final answer. So please remember, when you're adding and subtracting decimal numbers, you must line them up at the decimal. Question 16. Okay, so 0.2 times 4. Right, I want you to be careful with these questions, okay? You're doing a decimal times an integer value now. We're going to pretend that we're doing 2 times 4, okay? So at the moment, yes, we have 0.2 times 4, but we're going to pretend it's 2 times 4, and 2 times 4 is 8. Here's the thing. I actually had 0.2. So once I figured out that the 2 times 4 is 8, I need to look at how many decimal places I had in the question. And I have 1 decimal place. So that means my answer also needs 1 decimal place. So it should be 0.8, because that is also 1 decimal place. Okay? Right, so pretend you just have integer values, and then you can put your decimal places in. So let's try part B as well. Part B says 5 times 0.7. So 0.7 times 5. Right, ignore the decimal. 5 times 7 is 35. But we do have 1 decimal place. And so our answer should also have 1 decimal place. So it's 3.5. Right, I hope you get that. Right, you multiply as if it was just normal integer values instead of decimal values. And then at the end, we put in our decimal places. Good. Right, part C, we are now dealing with division. Here's where I'd really like you to use a fraction again. It's going to help you. 1.8 over 3. Okay, let's cancel down first. Right, we have 1.8 and a 3. Well, we can pretend that that's 18, definitely. And if I do 18 divided by 3, I get 6. So instead of 6, there's 1 decimal place, so we can think about it as being 6, okay? But actually, we need 1 decimal place, so it's 0.6. All right, so let's just review that again. Write it as a fraction to help you out. If you pretended that that was 18 momentarily, yes, 18 divided by 3 would be 6. We wrote down the 6, and we looked, actually, no, can't be 6 because there's a decimal place there. It must be 0.6. Okay, so once again, if I have 1 decimal place here, then I better make sure that I have it there. Okay. And part D, okay, 2.4 divided by 6. Let's momentarily pretend that that is 24. We know that that would give me 4, but I do have one decimal place, so it can't be 4. It must be 0.4 because that gives me my one decimal place that I had in the question. Okay, so well done. Right, so for question 17, what they want us to do is figure out what our power must be. So 5 to the power of something is equal to 25. Well, I know that 5 times 5 equals 25, so that must be 5 squared. So that should have been a 2. And for part B, we have 3 to the power of something equals 27. Well, 3 times 3 times 3 is equal to 27. So that's 1, 2, 3. 3 to the power of 3. So our answer should have been 3. Well done. Okay, your turn again. Press pause and try questions 18, 19, and 20. And press play when you're ready to go through the answers. Well done. Okay, very good. Let's look at 18a. So this is saying we have to find 20 squared. Well, 20 squared we know is 20 times itself. Okay, which is going to be 2 times 2, which is 4, and then times 10 times 10. Okay, there. And gives us 400. Part B, 6 to the power of 3. Okay, so that's 6 times 6 times 6, which gives us 36 times 6. If you can't do that in your head, it's not a problem. Write it out like this now. Okay, 6 times 6 is 36. Carry the 3. 6 times 3 is 18. Okay, let's add that up. 6 plus 0, 8 plus 3, 11, carry the 1, and then a 2. Okay, so that's 216. Good. Right, question 19 is looking at order of operations. Okay, I know you've heard of BIDMAS, which normally works, but I'd rather you think about it as order of operations. So your brackets are going to come first because they're being separated out as something you need to do first, okay? All right, so let's take a look. For part A, we have 8 minus 5 in a bracket times 3. So we do 8 minus 5, which is 3 times 3, which gives us 9. Okay? Part B, we have 12 divided by 7 minus 4. So again, I have to do what's in the brackets first. So that's 12 divided by 7 minus 4 is 3, and that will give me 4 as my final answer. Well done. Okay, in question 20, we are looking at putting the correct sign. Now that's called an inequality, okay? All right, and the first one means less than, and the second sign there means greater than. And we need to put that in between the numbers to make them true. So if I have a 1 and a 7, we know the 7 is greater than the 1, so the 1 is less than the 7, so it looks like that. 1 is less than 7. Part B. 0.8 and 0.2. Well, I know that 0.8 is greater than 0.2, so that's my answer. Part C, negative 4 and 3. Well, negative 4 is less than 3. And part D, we have a negative 1 and a negative 9. Careful, negative 1 is closer to 0, so it's closer to the positive numbers. That's smaller, so that should say negative 1 is greater than negative 9. All right, so just be very careful with your negatives. Yes, 9 looks like a bigger value, but remember, of course, that it's negative, and so it's actually a lower value. All right, good work. Okay, so we are now going to move on to our measures. Well done on your number work. Right, I would like you to pause and have a go at questions 21 to 23, and then I will go through them with you. So just pause, try them, and then we'll go through them. Right. Okay, so question 21, we are dealing with a square, And it wants you to find the area. So before we do this, let's just remind you that the area of a rectangle is length times width. Now, a square is technically a rectangle. It's just a special type in that all the sides are the same. Okay, so for this question, area would be equal to 7 times 7, which would be 49. But remember your units because its area are squared. Okay, so that's 49 centimeters squared. Final answer. That's question 21. Oops, 22. Let's take a look. We have Sienna buys a cup of coffee for £2.60 and a sandwich for £5.95. How much change would she get from a £20 note? Okay, so there's two things I have to do. I'm going to have to add together and get the total she spent. So let's do that first. So we've got 2.60 and we are adding 5.95. 5, 6 plus 9 is 15, carry the 1, don't forget your decimal, 2 plus 5 is 7 plus 1 is 8. So she's spending £8.55. When I write out the £20, I'm going to want 2 decimal places because that's what money has in terms of our pennies, okay? And underneath the £8.55, subtract, remember, line up at the decimal. Can't do this, okay, at the moment, so I'm going to have to exchange. I still have to exchange again, make that a 9, make that 10, and exchange one more time. Now I can say 10 minus 5 is 5, 9 minus 5 is 4, put my decimal, 9 minus 8 is 1, and then we had a 1. So she gets £11.45 in change. Okay, well done. Question 23. Jai has 4 parcels to post. Okay, they weigh 580 grams, 825 grams, 673 grams, and 742 grams. What is the total mass in kilograms? And they've given us a hint that 1,000 grams is 1 kilogram. Okay, and that's actually a really important thing to know. So you might want to write that in your notes now. 1,000 grams is equal to 1 kilogram. So if I ever wanted to find kilograms when I had grams, I'm creating a smaller number. So I would divide by 1,000 in order to convert grams into kilograms. If I ever wanted to take kilograms and turn it into grams, I'm creating a larger number, so I would multiply by the 1,000. Okay? So add that to your notes because that is super important to remember. All right, so let's do the question now. I'm going to need my total. So we have 580 plus 825 plus 673 plus 742. So we're adding all of that up. 5 plus 3 is 8 plus 2 is 10. 1 plus 8 is 9, plus 2 is 11, plus 7 is 18, plus 4 is 22. 2 plus 5 is 7, 7 plus 8 is 15, 15 plus 6 is 21, 21 plus 7 is 28. Okay, that's in grams though. We want to convert that to kilograms. When we want to go to kilograms, we're meant to divide by 1,000. So if I am doing 2820 divided by 1,000, that is 3 place values smaller. Okay, so that would be equal to 2.820 kilograms. And that is your final answer. Okay, well done. Okay, so next we're going to look at temperature. So pause, see if you can do that question, and then we'll go through the answers together. Okay, good work. Okay, so in this question, we are reading the thermometer. Okay, so I'm just going to show you with my arrow. The first thing they want is what's the temperature in degrees Celsius. Well, this is a different scale than the Fahrenheit, so we have to be really, really, really careful. So here, it looks like there's 5 sections between the 20 and the 30, which means that each little section, if that's 10, must be worth 2, because 10 divided by the 5 sections is 2. Now we have 22, then 24. So in terms of degrees Celsius, for part A, it's going to be 24 degrees Celsius. Part B wants us to find Fahrenheit, so let's be careful. Right, so that's 60, that's 80, this bit in the middle must be 70. Okay, again, we have 5 little sections representing 10, which must mean that 10 divided by 5 is 2. So each of these little guys, little sections, we call them, not guys, little sections, must be worth 2. Right, and I have 1, 2.5 sections, so that must be 5. So we can say 75. So the answer to this would be 75 degrees Fahrenheit. Right. So you have to be comfortable reading scales. You have to think to yourself, okay, what's that section worth? And then what are the smaller sections worth based on that? Okay? So well done those of you who got that. That's excellent and an important skill to have. Right. So continue with temperature. Okay. Remember when we did the plus and minus, or adding and subtracting, and we had positives and negatives? I talked a lot about temperature there, so I think you'll be okay. Try question 25 and 26, and then we'll go through them. Okay, so we've paused and had a try. Let's take a look. So for part A, it's saying what is the difference between 5 degrees and 12 degrees. Well, 12 take away 5 is 7 degrees Celsius. Part B, the difference between 8 degrees and negative 7. 8's the larger one. We are taking away negative 7 for the difference. Remember, when we take away a negative, it's the same as plus. So that's 8 plus 7, which is 15 degrees Celsius. And part C, negative 3 and negative 11. Well, our largest value is the negative 3, and we are taking away negative 11. Okay, now that's the same as a plus, so that's negative 3 plus 11, which is, well, we could think about that as 11 take away 3, okay, which we should know is 8 degrees Celsius. Good. Well done. Question 26. Says, the daily average maximum temperatures in Moscow range from negative 9 degrees Celsius in January to 23 degrees Celsius in July. What is the difference between these temperatures? Again, we're going to take the highest value and take away the lowest value. Right? Lowest value is negative 9, so I'm taking away negative 9. That's the same as adding, so that's 23 plus 9, and 23 plus 9 is going to be 32 degrees Celsius. Okay, well done. Okay, so the last types of measures we're going to look at are capacity, so volume, and also distance. All right, so just press pause, try question 27 and 28, use the hints to help you, and then we will go through the answers. Okay, well done. Let's look at question 27. Right, it says, how many 240 milliliter glasses can be completely filled with a 2-liter bottle of water? Let's pause for a moment and write down our conversion. So we have 1,000 milliliters is equal to 1 liter. Okay, if I want to go from milliliters to liters, the number will be getting smaller, so I am dividing by 1,000. And if I want to go from liters to milliliters, the number gets bigger, so I would be multiplying by 1,000. Can you take a moment to write that in your notes, because that is very important. Okay, so now let's take a look at the question. We need to figure out how many 240 milliliter glasses actually fit into a 2-liter, or sorry, can be filled with a 2-liter bottle of water. filled completely. Okay, so let's take a look at what 2 liters is. So 2 liters times 1,000 is equal to 2,000 milliliters. And we want to know how many of those 240s will actually fit into this. Let's use division, but in the way I taught you, where we use a fraction. So we're doing 2,000 divided by 240. Let's make this smaller so that we can understand it. First of all, they both divide by 10. So this is 200 divided by 24. Now they can both divide by 2, which is going to be 100 over 12. They still divide by 2. That's going to be 50 divided by 6. They still divide by 2. That's going to be 25 divided by 3. So how many times can you fill it completely is going to be however many times 3 goes into 25. Now that's going to be 8 times fully because 3 times 8 is equal to 24. Okay, so our answer is going to be 8 times. Can't get another 3 in there. 24 is only 1 away from 25, so that's why that works. Okay, and question 28. Abby needs 18.4 meters of skirting board. All right, before we continue the question, let's look at this hint. We're clearly going to need it. Okay, so we have 1,000 millimeters is equal to 1 meter. Okay, why is that? Well, that's because there's 10 millimeters in a centimeter and 100 centimeters in a meter. Okay, so that's nice of them to give you that hint. But you might have to figure it out yourself. Okay, right, so if we're using this conversion, if we're going from millimeters to meters, we would divide by 1,000 because the number is getting smaller. And if we were to go from meters to millimeters, we would times by 1,000. Okay, hopefully that makes sense. Right, so that's fine. So let's read the question. Abby needs 18.4 meters of skirting board. So that's what she needs. Skirting board is sold in packs of 4 lengths. Each length is 2,400 millimeters. How many packs does Abby need to buy? So there's 2,400 millimeters in a pack. Okay, right. I can't do this yet because this is in meters and this is in millimeters. Easiest thing to do is to turn this one into millimeters. So we're going to have to multiply that by 1,000, and that's going to give me 18,400 millimeters, because remember, if it's 3 places, we need to increase it by 3 places, decimal places, okay? Right, so now we can divide. And again, we need a fraction for this division because that's a lot easier. Both divide by 100, so that is equal to 184 over 24. Both of those divide by 2. 50 plus 40 is 90, so 92 over 12. Both of those divide by 2. 45 plus 1 says 46 over 6. That divides by 2. Which is going to be 23 divided by 3. Okay, now you have to think how many 3's fit into 23. Well, that's 7 2/3. Okay, well, I can't have 7 2/3 of a pack. I'm going to have to buy enough packs to do this. I can't buy 2/3 of a pack, so therefore this is approximately 8. All right, so we can say that we would need 8 packs to make this happen. All right, I think you've done really, really well today. Okay, all of this is really crucial. All right, if you need to go back and look at anything again, please do. Okay, just go back to the question that you need and make sure you've understood everything. Okay, the parts I told you to put in your notes are really important. Okay, so make sure you've done that. And next lesson, we'll be moving on to the unit work for Unit 1. Okay, well done. Very proud of you and excellent work today.